Hello dear students, this is Ashwini S, Assistant Professor of Mathematics. The program is B.Sc, Subject Mathematics Paper 1, Semester 3, Unit 1, Mathematical Logic. The topic which we are going to discuss today is Introduction and Logical Connectives. Let's see its introduction. Mathematical logic emerged in the mid-19th century as a subfield of mathematics. It is also called symbolic language or symbolic logic. Proposition. A declarative statement which is either true or false but not both. Whichever statement we take, it can either be true or false, but we cannot have both of them. It is also known as statement. We denote this by the small letters P, Q, R, S and so on. Now let us consider the examples. Let me take P. So denotation is by P and I say Bangalore is the capital of Karnataka. Q. 2 plus 5 is equal to 7. Another example is R. 16 is a prime number. Next definition is truth value. The truthfulness or falsity of a proposition is called its truth value. That is, if a proposition is true, then we write it as capital T, and if it is false, then its truth value is capital F. The first example, so proposition, we take it as P. And the proposition statement is 8 is prime number. We know 8 is not a prime number, hence it is false. Its truth value is F. Q. New Delhi is the capital of India. This is true. So hence its truth value is capital T. Compound proposition. When we say compound, it is more than one. So two or more propositions which are combined using some connectives are called logic compound propositions. The proposition without logical connectives is called simple proposition. So any statements which is two or more than two are connected using certain word or connectives. So they are known as compound propositions. Now in the given example, it says all triangles are equiangular and square has 4 sides. When you look into this, there are two propositions. The first one is all triangles are equiangular. The second one is square has 4 sides. The logical connective which is used between the two statements is AND. So let's see what are these logical connectives. So the connectives which or phrases which we are using here are AND, or, if then, if and only if, and not, NOT, not. So these phrases are known as logical connectives. So we can generalize that there are 5 logical connectives. We are going to study each one in detail. The first one is negation. A proposition obtained by adding the word not at an appropriate place is called negation of the given proposition. That is, in a given statement, you have to add a word not at a particular sentence. For example, I'll say, Bangalore is the capital of Karnataka. If I have to write its negation, I should be writing it as Bangalore is not the capital of Karnataka. So the appropriate place is very important in this. Now I'll take the proposition to be P, and when I take its negation, now this is the symbol which we write it as negation P. So when I take the truth table, since P is a single proposition, it can either be true or false. The first column I write it as P, the first value I take it as capital T, the next value I take it as capital F. Second column I write the symbol negation P. So negation of capital T will be F, negation of capital F will be T. So it says if P is true, then negation P is false. If P is false, then negation P is true. Now let's see the second one, which is known as conjunction. A compound proposition obtained by combining two propositions by using the word AND is called conjunction of the propositions. That is, two different propositions will be given. They will be connected by using the word AND, AND. So the symbol represented is P and Q. This is just the upper side of V. Now let's see the truth table. Since we have two propositions here, we will have 4 different combinations. The first column will be P, second column will be Q, the third column will have P and Q in symbol. So when there are 2 different propositions, the simplest or the shortcut way to write P is, what you have to do is, in the first column, we will first write the 2 lines as capital T followed by 2 capital F. So in the second column Q, First we will write it as T, then capital F, and then we repeat the two things. Now since it is AND, what we have to do is we will be checking for both the conditions. That is, if both the propositions are T, then its answer is also going to be T. If either of them is false, then the entire answer is going to be F. So it is written down in the words as P and Q is true only when both P and Q are true. In all other cases, it is false. The third one is known as disjunction. So the definition is a compound proposition obtained by combining two propositions by using the word or is called disjunction of the propositions. So the symbol is P, or this is read as P or Q. Now here truth table, again since we have two propositions, we will be having 4 different combinations. So the first column is P, second column is Q, third column is P or Q in symbol. Now since this is or, it is whenever we say or, it is either one of them. So when you're writing the truth table, we just have to remember that if either one of the combination has T or both the combinations as T, then a final value is going to be capital T. When both of them are going to be F, our final answer is going to be F. So that is what it says. P or Q is false only when both P and Q are false. In all other cases, it is true. The next one is conditional. We also call it as implication. A compound proposition obtained by combining two propositions by using the phrase if then at an appropriate place is called conditional of the proposition. So again here we will be considering two propositions P and Q. Then the conditional is denoted by P implies Q. The single arrow mark or double arrow mark in short can be written as implies, or it is read as if P then Q. Now let's see the truth table. Now since here again we have two propositions, there will be 4 combinations. First row has 2 T's and 2 F's. Second column has 1 T, 1 F, then 1 T, 1 F. Now this P implies Q is false when the first proposition will be true, the second proposition will be false. Here the first proposition is P, second proposition is Q. So it is false only when P is true and Q is false. In all other cases, it is going to be true. The last one is biconditional, which we also call it as equivalence. A compound proposition obtained by combining two propositions by using the phrase if and only if at an appropriate place is called biconditional of the proposition. So here we say let P and Q be two propositions, then the biconditional is denoted by, here we will be having double side arrow mark or double implication. It is read as P if and only if Q. The truth table, again since it is P and Q, we have 4 combinations. Now since it says if and only if, the condition has to be satisfied both the sides. So it is going to be true only when both P and Q will be true or both F will be true. In all other cases it is false. So that is the reason the first one and the last row has true values. The second and third one has F. So the references which I have used here is Elliot, Mendelson. The book is Introduction to Mathematical Logic from Wordsworth and Brooks, 1987.